Good day, grade 12 learners. Welcome to today's subject, Technical Sciences subject lessons. My name is Jabu Sitole. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we are going to prepare ourselves for tomorrow's exams. We know for the fact that tomorrow we are writing Technical Sciences, paper 1. So we are trying to just remind ourselves of what we have learned during the year. So for our preparation, we are going to look at all the topics for paper 1. But if the time allows us, yes, we'll look at all of them. But if the time, we have a limited time, we'll just skip others, but we'll make sure that we do most of them. Right. Now, let us go quick. If you look at the structure of the question paper, there's a section A, which is 10 questions of a multiple choice questions, and those questions are 20 marks. In other words, there are 2 marks each. So 2 times 10, 2 times 10 is going to be 20. Then you might have, like we saw in our mock exam, matching the column. The matching of the column is 8 marks, which is 1 mark each. And then we've got section B. Those are structures questions, or we term them long questions, which are 120 marks. So all in all, you are going to be sitting for 3 hours for 150 marks. That is the allocation of the paper that we are going to be sitting tomorrow writing. Now, if we look at the structure now, in terms of each topic and question, in the structure of paper 1, we've got question 1 until question 10. Question 1 is multiple choice, is what I've alluded in the previous slide. That question is 20 marks. And this question, it's where learners, they just pick and choose. They don't read. So we'll go through this question and see how far and how well are you going to answer that question. Question 2, it's force and Newton's laws. It's plus minus. Now, I said question 1 is 20 marks. There's no plus minus there. It's 20 marks, period. Now, the other questions, they can be more or less. So that's why I put plus or minus, so they can be more or less. Now, let us look at question 2, forces and Newton's law. Those are, they warrant us how much? Plus minus 12 marks. You should grasp the marks. 12 marks, and at least get half of 12. Then we've got question 3, which is momentum and impulse, plus minus 14 marks. Remember, in all of these questions that we are alluding to now, they've got definitions. They've got where you can grab the marks and run, right? Now, momentum and impulse, it's plus minus 14 marks there. Then work, power, and energy, it's plus minus 16 marks. It means it can be over 16, it can be less 16, but average it can be 16. Now, elasticity, 12 marks, plus minus. Hydraulics, plus minus 8 marks. Electrostatics, plus minus 10 marks. Electricity, 9 marks, which is plus minus. And then electromagnetism, plus minus 8. And then light, it's 20 plus minus 22. Now, if we are a learner sitting now, writing and checking, you have to understand as to where would I grab the marks. Let us look at these marks once more. Now, where are the highest marks if you look at it? Light has the highest marks, which is 22 marks. Then out of 22, at least, you can get that 10 or 12 marks. Then you go to as far as momentum, 14 marks. Then you go to as far as power and energy. Work power and energy, which is 16 marks. So play with the marks, play where you are going to, figure it out where you are going to get the marks, because you are looking at this. This is the structure of the question. I'm not saying to you, this is the question paper. No, I'm saying this is the scope of the patient. If you can look at all the question, the structures like this, and they count the marks. And the marks that gives you more is that those of definitions and law and so on. Those are easy marks to grab. So these are the marks. This is the structure that we must look at. And as we are studying and sitting down, take this structure, strategize as to where would I get more marks. Look at where marks are, then you strategize. Now, what I'm saying is, as you have this structure, there is no way or instruction that says to you, you start with question 1. Or you start question 1, you follow with question 2. No, you can start with any question as long as you number it correctly. That is very important. You can start with question 10. Then you deal with question 10, you end up with that question 10, number it correctly, then you go with question 5, then you go with question 2, as long as you are going to number them correctly. That is very important. So this is the structure. I want you to just copy this, and then you start now strategizing as to where would I get marks, or where would I start, which question I'm going to start with to get marks, right? The skill, mathematical skills. We know for the fact that when we are dealing with scientific numbers, we need to do scientific notation. So it's very important that you convert if you've got the bigger numbers, you converted them to smaller numbers, you use scientific notation. It can be 3 times 10 exponent 3. That is scientific notation. This is from 0,03, right? This is your scientific notation. So you can expand or you can squeeze your numbers using scientific notation. Conversion of units is very important. We normally use meters, right? Now, if you have kilometers, convert kilometers into meters, because we don't calculate with kilometers. We calculate with meters. So it's very important, conversion. I'm just reminding you what we have learned. Now, vectors. We know vector is a quantity that has both magnitude and direction. Now, direction is very important. Remember, even scale has a magnitude. But this one has both magnitude and the direction. So direction is very important when you're dealing with vector. You know, if we talk about direction, we talk about plus or minus. Those are direction. We don't add. If you get your force being negative 5 Newton, it tells you the direction, which direction it goes. You get the acceleration as 2 meters per second. There's direction. The 2 there in front of the 2, there's plus. Then it tells you it's moving forward. So it's very important that you use the direction. Then interpretation of graphs. We know if you've got a graph like this, what does it mean to you? It's a graph of proportionality. So this is a very important graph. So interpretation of graph, interpretation of data is very important. So here we just reminding you that you cannot calculate without using the skill of mathematics. So it's very important, learners, that you take step by step. You look, you read, then you convert, you interpret what is it that you are reading. That is very important, right? Formula sheets. Many a times we are saying this is where we are going to get the lot of information. Your information, your definitions lies on the data sheets. If you want to know what is Newton's second law all about, go to your data sheet, look at this one formula. This formula will give you what? Newton's second law. You will be able, you don't have to claim Newton's second law. It is there on your data sheet, and the data sheet is behind your question paper. You are allowed to peruse your question paper and go and look at the formulas that you want. So this is very important. So the skill of using this, the skill of getting if you start with the word problem, you collect data. Once you have your data collected, then you look at the correct formula or equation at the back of your question paper. Then you pick up the correct one. Then you substitute. That is very important. So this is a skill that you have learned from your teacher. This is the skill that you have learned at school, that I must use what? The data. Without the data sheet, without the data sheet or formula sheet, you won't make it, because you will formulate your own formulas, then you'll get wrong. So these are the formula or equations that you'll get from the data sheets. Not this only, there are more, but these are the example for the forces. All right. Now let us go to multiple choice question. Question 1. How do you answer question 1, multiple choice questions? Many a times learners, what they do, they just look at the question, then they see the possible answers, which are 4 possible answers. Then they close eyes and then pick. Then they say that's the correct answer. It doesn't work like that. What you do first, start by reading. This is very important. You read the question carefully. You start by reading the question carefully. You read. Learners are lazy to read. Here you read the question, understand what does it question require you to do. Then you underline the key words in the question. You underline the key words. As you are reading, underline what they are saying, because some of the words, they are telling you what to do, or they are giving you direction as to which answer you are going to pick. All right. Then pay attention to the capitalized words. You pay attention to these words, because there are words there that are being bolded. There are words that are being capitalized. So you pay attention, because they give you a clue what to do. Decide whether you are required to recall or use fact, phenomena, definition, units, or formulae. Now, most of the time, multiple choice question is for recalling. They want you to recall because you understand, you read the thing. Recalling means remembering things. So you will be having definitions, you'll be having answers that need clarity. So they want you to recall. So decide whether they want you to recall. You use facts, phenomena, you use definition, formula, and units. Those are the things that you must understand what they want from you. You will see as we move along. Then what you do first, and I want you to listen carefully, learners, that is the first step that you do. Read the question, Then after, what you do, you eliminate. We are going to do the process of elimination. In doing multiple choice, you start by eliminating first before you can choose. Now, learners, they just choose they cannot see. So you eliminate. Then first select the correct answer from the others that remains. Then cancel the others. You eliminate. Now, how do you eliminate? I want us to go to the multiple choice question. Now, this is a question 1 that we have. Let's read fast. It says a fly hits the windscreen of the speeding car with a force F. We are giving force F there. Which one of the following statement is true? Which one out of the 4, the following statement is true. Right? That they are asking you, which one? Remember, we've got a fly that was flying and hitting the speeding car, then with a force F, then which one is true? The magnitude of the force exerted by the windscreen on the fly is, now you compare the two, the magnitude of the force that is exerted on by the windscreen on the fly. What is it? Right. Now, let us look at it. What comes to your mind is, look at for those wrong first. We eliminate. We want the wrong ones before we can start with the correct one. We don't know. You start now. I can see we are start thinking. We are starting saying this is it, because you don't apply your mind. Apply your mind. The magnitude of the force applied by the windscreen cannot be less than F. Right? We agree. Cannot be less than F. The magnitude of the force you cannot say it cannot be determined. The force can be determined. We can calculate the force and get what force is it. So it can be determined. So this one, saying it cannot be determined is wrong. Now we have eliminated the two. Remember I said the process is for elimination. We have eliminated the two. Now we have left with the two. We must find the correct answer. Now, here we need to read the statement and we recall. Remember, this question is for recalling, remembering what we have read. They say the magnitude of the force exerted by the windscreen on the flight is, remember, the flight hit the windscreen of the car, and then the windscreen of the car hit the flight, the fly, right? So it means this one hit that one, this one hit that one. There in your mind, there's a law that is coming to you, that is telling you. There's a law that is saying when two objects exert a force in each other, right? They've got the same magnitude, but acting in the opposite direction, right? Same magnitude, yes, calm the mind. Same, or they have equal magnitude, but acting in an opposite. Equal, same. Equal, same. Now it comes to your mind, which is an answer now, because it says same or it says equal. Now it means therefore B cannot be great. Then the answer is equal. Remember Newton's third law. I've applied Newton's third law. It's a recall. It makes you to recall Newton's third law. I've just said to you Newton's third law. Action, reaction, force. So that is action, reaction, force. That's why the answer is B. So the system of elimination here, it works, right? So I've tried to eliminate. So hence, I got the correct answer. You can verify, then, but you can go to Newton's third law. It will tell you, right? Now, here's the example number 2. Which one of the following statement best, big capital word, best, explain why the momentum of the object is a vector quantity? Yeah. You see, I read. You don't read once, you read twice or thrice, so that you understand. Which one of the following statement best? They want the best, not most or less. The best that explain why the momentum of the object is a vector. Come to your mind. Come to your senses. What is a vector? What you are looking at a vector? I said it on the first slide. We are looking of direction. Remember? No. You are looking of the direction, because a vector is a magnitude that has both magnitude and the direction. A scalar is a physical quantity that has a magnitude only. So this one has a direction. So we are looking at the direction. So look at the answers that has a direction. Those that has not direction, you eliminate. Now let us go there. If you look at number C, it has a magnitude equal to the velocity of an object. There's no direction there. We eliminate. D, it has a magnitude smaller than the velocity of an object. There's no direction there. We eliminate. Now, we've got A and B. They both has direction. Now we need to go back to read the question. Which one of the following statement best explain why the momentum of an object is a vector quantity? Momentum, the velocity of the momentum cannot act in an opposite. We know that one. It cannot act in an opposite. Now, let us make an example. This is an object with a mass kg. Then we push that up, or the object is moving in this direction with meters per second. And we know that meters per second or kilogram meters per second is momentum, right? It's momentum. So the momentum, the object is moving in a direction of what? Of the velocity. Meters per second is a velocity, isn't it? So the object is moving in a direction of what? The velocity. So which correct statement? The correct statement will be A. So B, it's wrong. So that is how you read. You must dedicate yourself to read this question. Then you try to eliminate, and then, but at the same time, you recall, because this is very important. Is about recalling. So this is multiple choice question. That is how you are going to strategize. If you want 20 out of 20, I'm telling you, you can still do it. 20 out of 20. You can still get that 20 out of 20 by doing what? Elimination first. Then you will get your answers, the correct answer, as you read along and you remember what you have learned. But if you don't study, even if you can read, you won't make it. So I know you learners, you are good learners. We have read, and you are going to pass it. You are going to get 20 out of 20 in the multiple choice questions. All right. Let us go to question 2. This question 2, it relates to us, to Newton's laws and forces. But I'm going to dwell in Newton's laws. Now, we've got 3 laws that we need to look into. Now, these laws are Newton's first law, that we are talking, this is our center. This is a force and laws. Now, the first law, this is the first one, which is Newton's first law. You know, we need to state what is Newton's law. What does it say to us? But what we are looking at when we talk about Newton's first law, we are talking about when the object, it can move or it can be at rest, right? But if it moves constantly or inconstant or is in constant motion. Now, if the object is in constant motion, this is the word constant motion. What does it tell you? It tells you that acceleration is equals to 0, because there's no change of motion there. So it moves constantly. And we know that for the facts in this law, net force is equals to 0. Right? Once you look at the object while it's at rest, once it's at rest, because this start by the object will be at rest or move in with a constant velocity. So once it's at rest, we must know that the net force is 0. Once it moves constant, the acceleration is 0. So this is very important. So this law, that is what you look at. Right? Law number 2. This law number 2, that is where there is a net force and acceleration. Because if a net force is applied on an object, the object will accelerate in the direction of the net force. So this is the law where there is movement. So there is acceleration there, and there is what? A net force. A net force. Now, I'm not saying a force, learners. We are not talking about we're talking about the net force, the addition of force that is acting upon the object. That's or the sum of forces that are acting on the object is how we define net force. All right. So this is the second law, and this is the law that is very important. All right. This, all of them, they're important, but this in terms of calculations, because you are going to do calculations there, right? Now you've got Newton's third law. Newton's third law is the one that I've related to when we dealt with the multiple choice questions. So it says we normally call it action reaction force, but we know that it involves two objects. This one involves a single object, this one involves a single object, but this one involves two objects, because two objects must exert a force to one another, and they act in an opposite direction, but they have equal magnitude, right? So this is Newton. These are Newton. So you cannot cram these laws. Please, don't cram. Don't cram. This one, this you get it from your data sheet. This is the law. Acceleration is directly proportional to the net force, and that acceleration is inversely proportional to the mass. So you've got the mass, you've got the acceleration. So that is the law. So I've get it from where? The data sheet. I don't have to cram it. It's there. I pick it, then I said it. Speak to it. So if you want to close your eyes and want to cram, the fly will come. Once the fly comes and pass, you will forget everything. So don't allow the fly to come and pass. So know what is it, right? So this is how you are going to deal with the laws. So let us go deeper in this one. Now this is Newton's first law. I said this is acting on a single object. What does Newton's first law says? An object continue in a state of rest or uniform. Rest, we said F net equals to 0. Or in a uniform velocity, or uniform or constant. Uniform constant, we say acceleration is equals to 0. So this is the law. You must know how to state the law. It's 2 marks or 0. 2 marks or 0. So you cannot drop these 2 marks. So this is 2 mark or 0. Now, this is the law. You must know how to define the law. This law based on what? On the constant, the object at constant, and the object at stationary. Stationary means at rest. All right. Now, it's what I've explained. So this one as well, it's formed on a single object, or is acting at the single object. Now, this one, there is motion. There is a net force that is going to be applied, and then after that, it's going to be the force that is going to be applied, and then after that, you must know that there is motion, there's acceleration that is going to happen. So can I just give you a minute so that you can think about these laws? Now I give you a minute so that you can think about the Newton's third law. Just a minute, then we come back.
Excellence. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Welcome back. I understand that we have thought about the little bit of a classwork that I gave you, or the activity that I gave you, Newton's third law. Now, it explains itself, right? Newton's third law, what does it say? It says when two objects, it's acting two objects. Here is two objects. We said this is single, this is single, this is two objects exerting a force to each other. So I said you must understand how to say this law. This law, it says a net force acting on an object will cause the acceleration in the direction of the force. This acceleration, we talk about the acceleration, is proportional, directly proportional to the net force and inversely proportional to the mass. So you don't have to forget. So in this one, you're going to use net force equals to MA in this one. You're looking at your data sheet, right? Then this one is when two objects exert a force to one another, and then they are acting at an opposite direction, but they are having equal magnitude. Did you see that? Where comes the answer? Here. So they are acting at the same object, but in an opposite direction, but in an equal magnitude. So this is the law that you need. This is a must that you know. Right. Now, how to solve a problem using those laws or Newton forces and the force. Newton's law, they are following important. Read the scenario carefully before attempting to respond. Identify whether the scenario involves Newton's first law, Newton's second law, Newton's third law. Either way, the scenario can be Newton's first law, it can be Newton's second, it can be Newton's third. Then keywords such as, listen to keywords as you read. Rest. I told you what rest means. It means rest. It means stationary. It means equilibrium. So it means the object is not moving. Then, if you go to acceleration, there is movement. In fact, this drawing is way around, because here, if it's rest and this must come here, and then this must go there, because there is a force applied in acceleration, right? Now, solve a problem. How do you solve the problem? Newton's laws follow the important following. We need to follow this important strategy. 1, identify the force acting on an object, right? We've got normal force, we've got gravitational force, we've got the opposing force, which is the friction force. You may name them. You've got the tension. All those forces. Identify which force is acting on an object. All right? Then you will be able to draw the free body diagram or the force diagram with those forces. Underline words such as rough surfaces or smooth surface. Pay attention to the marks. Marks are very important. So marks, they are giving you time as to what time you should spend on that question. They give you a directive as to how many points they need. Right. So pay attention to the marks allocated. If it's 3 marks, 3 steps. Right? Formula, substitution, the answer with SI unit. Right. Now, for equation the question involving equations. Now, this one, what you do, as I said there, you look at the marks. This, if it's a straightforward question, we're going to do it now. A straightforward question is going to be 3 marks. It's very straight. If they say calculate momentum, you go and pick up the formula for momentum, P equals to mv. Then you put it there. Then you go to the problem with, you identify the data that they need you substitute, then you come up with the answer. That is 3 marks. So, but if it's the multiple step, it's allocated 4 or more, because the answer that you got is the answer that you are going to use. You carry over to use it. We call it a multi-step, right? So we are taking the answer from the one that we have used maybe in 1.1, then you use it in 1.2. That is multi-step. You are using that answer carrying throughout, right? So it's very important. Then pay attention to the vector. We know that what is the vector we're looking at the direction. So it's very important. So now there's not only those things, there are free body diagrams. And that's where you need to get a lot of marks when we talk about free body diagrams. We've been doing free body diagram from grade 8, grade 10, grade 11, we are in grade 12 now. You are still not able to do a free body diagram. So free body diagram, there's a difference between a free body diagram and the force diagram. You look into that the normal force. The normal force always is exerted by the surface on an object and act perpendicular. If you've got a surface like this, where will be your normal force? Your normal force will be perpendicular. Perpendicular means 90, perpendicular to the surface. This is your surface. This will be your normal force. So that is what it says. So that is a normal force. Always label the forces. Use symbol. Now this is a normal force, which is going to be N or Fn. That is normal force. All right. So the frictional force is that acts opposite to the motion of an object. That's the frictional force. We know about that one. So I want us to go quick, very quick, because we are against time. Now, this is where we are going to be penalized. All right. Do not leave out arrows or arrowheads when drawing a vector represented by force. This is a big wrong. This, we call it a vector. This is no longer a vector, it's a needle. It's a head and the tail. So it must have an arrow here that it represents a direction, right? Remember, we're talking about vector. Now, at one point, the dot is very important. If we're talking about the free body diagram, we use a dot, but the dot must be attached to the arrow. Sorry, to the, the arrow. So the dot must be, if you leave a space like this, you're going to get wrong. There should be an attachment. If you draw this one, it should be a dot here, then start there, then it's there. All right, it's very important. So those silly mistakes, they make you to lose marks, because I know there's anxiety, you want to speed, but be careful as you are drawing your vector diagram. It's very important. This one is where you must get marks. Now, always check marks awarded to the question. This, I bold it and I make it red. Mark allocate, so that when the number of forces drawn equivalent must be equivalent to the marks. If they say draw a free body diagram, then you check the marks, they say 4 marks. It means the force that you are going to draw, they must be equal to the number of marks that they are allocated. In other words, we are going to draw what? This is a free body diagram. We denote it with a dot. Now, this is going to be the dot. Gravitational force, Fg. This is going to be Fa, applied force. This is going to be Fn, which is normal force. Then we've got this one, which is Ff, frictional force. So the number of forces must tally with what? Your marks. So they tally. Once they tally, you know that you score. So don't draw less or more. It's 4 or 5. So if 5 marks, it's equals to 5 forces, right? If it's 2 marks, equals to 2 forces, right? Let's move. Now, this is a free body diagram, as I've alluded, but this one's acting vertical, right? If it's acting vertical, it means we've got an object hanging Let's say is the single there, is a ceiling there, and the object is hanging there. They say draw a free body diagram or a force diagram. We know that if we draw a force diagram, this is the force diagram, you must have a normal force. This is the normal force, right? And the normal forces must be perpendicular to the surface. Then we've got the free body diagram, I mean the gravitational force, which is acting downwards. Now, it start at the center. It shouldn't be starting there. You are wrong. Once it's there, it's wrong. It should start at the center. Is the force that attract an object from the center of the object down to the earth. So it must start there at the center. In the force diagram is the one that is tricky, but many times they do ask the free body diagram, which is easy. In a free body diagram, you only draw a dot, you draw a force downward, a force upward, and a force downward. Then you label, this is NF, this is FG. All right, 2 marks. This one is 2 marks because only 2 forces that are acting here. All right. This is the force diagram again. So if you look at this force diagram, now what do you do? This we've got a free body diagram, I mean a force diagram and the free body diagram. Now this is 4 marks, is what I've alluded. Now if they say draw a force diagram, you must draw it correctly. That is the problem with learners. Now they do it so quickly in such a way that they think that they will get marks. Now if you draw it like this, then you label. Do you get marks? Yeah, for your effort, I can give you 1. But you didn't define. Remember the definition of this one. It said it must be perpendicular. This one must be at the center. This one must be parallel to the surface. All right? Even parallel, it must be closer to the surface. It must not be seen, but we want to see it. So if you can check here, it's closer to the surface, which is the frictional force. This one, so I'll give you that one right, but the rest I'll give you wrong. So it's very important that you draw this with the definition. What is the definition of the normal force? What is the definition of the gravitational? What is the definition of the frictional force? So draw it correctly. If it's the force diagram. A free body diagram, there's no problem with that. Because we are going to draw a dot. We represent this with a dot. So you don't draw the box, you draw the dot. Then you draw the force, which is the normal force. You draw the gravitational force, which is Fg. This is N. Then you draw, this one must be longer because it's applied force. This one must be shorter, which is the friction force. So this cannot be equal to that one. Remember, this is the friction force. This must be longer. This has to be the shortest. So if you draw it longer, they will mark you wrong. So please guard against this one. But it's where you are going to get marks. It's free marks, right? So same thing when the force is acting at an angle, right? Now this is the free body diagram. Now if it's acting at an angle, we are given an object like this, then the force is acting at an angle. All right? And then draw a free body diagram. You'll be drawing something like this. This force is representing this. Then you're drawing like this. Or you can use components, right? Resolutions of components. So this is a component. This is f of x. There are 2 forces there. And then the fx. This is Fy and the normal and the f of x. This is going to be 1 mark, right? Then we've got 1 mark, and then the other mark, right? Remember, the other mark is for the normal. The other one is for a normal. The other mark, it goes with the f of x and the f of x and the f of y. It's 1 mark, then it's going to be 4 marks because this one, they are components. This one, it's component. So you can draw it like this, or you can use components of resolution of vectors or component of forces. So it's one and the same thing. It doesn't mean that you've got two forces there, you're going to get 5 marks. No. The two, the x, the force of x and the force of y, they are representing 1 mark. Then there we have got two forces. It's a normal and the f of y. The f of y, which goes with the f of x, then it's going to be 1 mark, right? So I think I'm clear. So this is the free body diagram. Then you are going to get the free body diagram. I show about that one because it's always there. And I've looked at the questions papers, it's always free body diagram. Then the free body diagram, please get marks. Look at the question. I mean the marks, how many marks it worth. Right. Now let us go to the calculations. That is where the nitty-gritty. All right. If we look at the calculation, it says a car, remember the strategy, you read. You read, it's very important to read, and then you underline. Right. A car is pulling a trailer with the mass. We are given a mass, is a data there, a mass of 650 kg at the constant. This one, you know what does it mean when you say constant, right? Constant velocity of 30 meters per second towards east, the direction, which is the vector, isn't it? Towards east, it's a vector, there's a direction. We're given a direction on a rough surface. The car engine the car engine applies a force to move both cars and the trailer at constant. Remember, when you say constant, immediately what rings in your mind? What rings in your mind? It rings that acceleration equals to 0. There's no change, right? That is very important. So there's a clue. Everything where you are reading, they give you a clue. So just interpret it. Just recall what does this mean. Now, that's where we start. You are giving the drawing there. This is a trailer. This is the car pulling one another. What is this? The tension, right? Right between the car and the trailer. Now, they say to you, state Newton's first law. Here they say first law because of that constant. Remember, all right? Newton's first law, if you state it, it says an object can remain at rest or move with a constant velocity, Newton, right? Not unless it's acted upon by the unbalanced force, resultant force, right? That is what the Newton, that is 2 marks. Learners, this is 2 marks or nada. 2 marks or 0. So this is your clue. This. Remember. What is tension? 2 marks or nada. Tension is defined by the force in the string or the force in the rope, right? The force acting in the rope or the force acting in the string. That is 2 marks. That's simple mark. If you stretch a rubber band or a rope, once you feel it, until when it doesn't stretch anymore, you'll feel the force there. That is tension acting there. So that is tension. So it's 2 marks. A force acting in the rope, 2 marks. 2 marks. Now, draw a free body diagram. Here we go. This question is always be there. Draw a free body diagram. Once you look at it, you look at the marks, 4 marks. How many forces? 4 forces. They want which one of a trailer. Then you go to a trailer, you do this. You draw this, you draw this, you draw this, you've got this. Then this is not a free body diagram. You go to a free body diagram, you say the dot, you represent the trailer with a dot. Then this, it's your tension. Then this is your FG. This is your FF. This is your FN. 4 marks. Right. Now, they say if the trailer is replaced by another trailer, if the trailer is replaced, you remove this one of 650, then you place another one of 750. So, how will the impact on the tension in the string? How will the pulling in the string, how will be the effect in the string? It will increase, it will decrease, it will remain the same. This is the free 2 marks. I take this trailer, it was 600. I replace it with the bigger one. What is going to be the tension? So because the mass now is bigger, the answer is going to be increasing, because it's going to increase because of the mass, isn't it so? So that is how you look at it. That's how you read. All right. Now the driver puts her book on the seat while driving. She then sees a donkey in the middle of the road and then suddenly apply the brakes. Now there's a driver, he's putting the book, and then he's driving. He sees an obstacle, then he braked. What is going to happen? The question is say, what will happen to the book as the brakes applied? Right? You choose here. You just imagine. You choose moving forward, move backward, remain the same, in the same position. What is going to happen to the book? It's going to move forward, it's going to move backward, it's going to remain the same. Now, if you apply the brake, now you come to your senses. There's a scientific law that is applying here. So you must think which type of a law, because the next question is asking you which law. Now, if you sit at the taxi, then the taxi suddenly, the driver is speeding at 120 meters per second, then you apply a brake. What is going to happen to you? You are going to move forward, isn't it so? Is what is going to happen to the book. So it's going to move forward, right? That is our answer. Why you say that? So you must elaborate which scientific law. Now, it's Newton's first law. If we are talking about the law, it's Newton's first law. You know that the object can remain at rest or can travel in the speed of the car. So, right, it can travel with 30 meters per second, because they were traveling 30 meters per second. So, it's Newton's first law, or it can be inertia, the law of inertia, which is within the Newton first law. So, it can be inertia. What is an inertia? It is a tendency of an object to resist the state of motion. So the object will resist, instead of sitting or standing or sitting without moving, is going to move forward. It resists the state of change. So there are two principles. It's a law or the principle. We are going to use the law or you use the principle. So here we have used, if you say the law, then you use Newton's first law. Then if you say principle, we use inertia. Then that was 2 marks. So don't you think that 14 marks was easy? It's a recall. It's a recall questions. We don't just pick. You and us, you just pick and say, then it's move forward. It's move backward. It's not piggy here. You just read the question, right? Now, we are question 2. We go to question 3. I'm a little bit behind. There are 10 questions. So, question 3. The following definitions are very, 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 very important. Why they are very important? Because they worth 2 marks. The definition worth 2 marks. So, they are very important. Momentum. What is momentum? Newton's second law. This one is Newton's second law in terms of momentum. Remember, we've got Newton's second law and Newton's second law in terms of momentum. Right. Now, we've got net force. What is net force? The sum of force acting. All the sum of force acting in an object. This is the sum. All right. That net means sum. All right. Impulse. Then this very important that you know what is impulse. Isolated system. What is isolated system? And then the principle of conservation of linear momentum. Now, then elastic and inelastic. So these are the definitions that you need to know if you want to get marks. Either of these is going to come up in the questions. So you must know what is it how we are going to answer it. You will see as we move along. Now, we still end that. What is impulse? Impulse is the product of a net force acting on an object at the time the net force is acting on that object. Impulse, it's a net force. Is this net force acting on an object? Right? At that time, this is the time. At that time, the force is acting on that object. So, impulse always is F net delta T. This is impulse. This is impulse. We're talking about impulse. And the impulse is not a net delta T equals to change in P. This is not impulse. This we talk about momentum theorem. This is momentum theorem, is not impulse. Impulse, we talk about this. This is what happened at that moment, at that time, right? Is that force apply and react at that time. That is an impulse, right? Now, we said we use Newton's second law in terms of momentum. Newton's second law in terms of momentum. This is a Newton's second law in terms of momentum. Then the net force acting on an object is equal to the rate. Rate is change in time. That is rate, right? Of an object momentum change of momentum of an object. So now this comes from where? Comes from here. Comes from here. They make a subject of the formula. They make A. They divide it by T, delta T, divide by delta T. Then you cancel delta T. You get something like that. All right. So this is the formula that you need to know, or the interpretation of Newton's second law in terms of momentum. This is Newton's second law in terms of momentum. You'll get this in your data sheets. All right. Now, the strategy to calculate. What are the tips to calculate momentum? Read the scenario carefully and underline the weights is what we are saying. I want to emphasize and put that because I emphasize it. You read carefully. Then you remember that we have V, we've got P, we've got change in P. V is for velocity, P is for momentum, delta P is the change in momentum, and the average force. All are vectors. These are vectors. They've got both magnitude and direction. We know that momentum has both magnitude and direction. So these are vectors. What are vectors? We look at the direction and the magnitude, right? Refer to the data sheet. This is very important. You'll get the data sheet. You'll get the data sheet at the back. Then we've got the formulas at the back. Pay attention to the marks. This is very important. 4 marks, how many marks? 5 marks, how many marks? And how much time do you spend to that question? Now, elasticity of collision. Elasticity of collision is there. It's where they say prove this is a elastic or not elastic. So you must prove. So it's when you prove using what? The kinetic equation. So it's where you compare or you prove. They'll say prove this is elastic or inelastic. So it means therefore you must get your answer. If it's equal, you conclude. If it's not equal, you conclude whether it's elastic or inelastic. So this is very important as well. So these are the tips that you must look at into as you are sitting tomorrow writing the question. All right, let us go to the question itself and then we move faster. We read the diagram below. An air rifle pellet of a mass of 2g, which is gram, is fired into a stationary block of the clay of mass 56 gram. Before it hits the clay, the pellet is traveling at the velocity of 140 meters per second to the right, given the direction. Upon impact, the pellet became embedded inside. It goes inside into the clay, and they move forward as a unit. They move together as one unit. Ignore friction. So now you've got this is, you say A, this is B, right? You've got A, which is the pellet. You've got B, which is the clay. Now, what is the question? The question says to you, define the following. These are 2 marks, 2 or nothing. Isolated system. Isolated system, you think of what? External force acting in the body, right? Outside. That is an external force. You think of external force, right? Now, this is what you are going to call it. I want to move fast because of the time here. Now, is then isolated is one in which the net external force acting on the system is zero. It's an external force that is acting on that system. It's equals to zero. That is the isolating. If we talk about isolated system, this is the formula that we are going to, the definition that we are going to define with. Then what is momentum? Thinking of only two quantities, a mass and velocity all the time. If we talk about momentum, what is momentum? It's a product of mass and velocity. That is momentum. 2 marks. So you don't have to go further. That is 2 marks, right? Now, you've got 4 marks now. We have said this one, we have said this one as definition, 4 marks. You want these 5 marks. You can make it, you can think that it's easy. Learners, they can get 0 there in that 1 mark, right? Because they don't think. What does that 1 mark says? It says, write down the magnitude, the size of the beginning or start. Initial momentum. Initial means start or beginning. Momentum of the clay. It means, what is the momentum of the clay? This one. This clay, B, at the beginning. They say the pellet is fired, the mass is fired into the stationary. That one, if something is stationary, what is the velocity? What is momentum? The momentum is equals to 0 because it's stationary. As we are sit there, we are stationary, we are not moving, we are at 0. So now, write down the magnitude of the initial momentum of the clay. What is the initial? What shows us that is it at initial state? Is at rest, then is that 0. So it means here, the 1 mark is 0. All right? There's no movement. So the stationary tells you, right, calculate the magnitude of the calculate the magnitude of momentum of the pellet before it hit the clay. Before it hits the clay. At the initial start. At an initial start, before it moves. So we want the momentum. We want to calculate the momentum here, the momentum. So calculating the momentum, we know that is P equals to mv. Now we are given the V there, we are given the M there, which is 2 grams. Now we go to the scale of conversion. We cannot calculate with the kilogram. So we need to do the the gram. We calculate with the kilograms. What do? We convert. We go to conversion. So what is going to be 2 gram? Is going to be 2 divided by 1,000. Now that is going to be 0. We add another 0 there. 1,000 goes how many times into 20? It goes 0. 1,000 goes how many times into 200? It's 0. Then 1,000 goes how many times there? It's 2 kg. Right. So your answer will be 0,002 times then 140. Then you calculate, you get your answer. So you will calculate, you get your answer. That is 3 marks. This is 1 mark. This is 1 mark. 1 mark. The answer must have what? Kilogram meters per second. The answer must follow with this. If there's no SI unit, we are going to get 2 out of 3. All right? So that is 3 marks. Now, state the principle of conservation of linear momentum in weights. Linear momentum in an isolated system. This is an isolated system. That where comes from, that word isolated, comes from this principle. A linear momentum is in a isolated system, right? So you go that way because we've got, in a principle, we've got the isolated. That's why they've asked you about the isolated system, right? It's called in both magnitude and direction. So this is the law. The linear momentum in an isolated system remain constant. This is very important. And then in both magnitude and the direction. So it's very important. So this is the law. Or this is the principle that they want you to state. So these learners, they are there in your exam guideline. These definitions are there. And I assume that the teachers, they've given you this definition. So use them, and the principle and the laws. So use them, right? Now, work, energy, and power. This one is very important as well to note it. Why it's very important to note it? It's because we are going to define what is work done. We are going to define the positive and the negative work. We are going to define the principle of mechanical energy, and we are going to define the power. This is very important. This, why it's important, is 2 marks. All right. This is very important. You must know that. So what is work done? Work done is a product of applied force in an object and the displacement, right? What is work? It's a scalar quantity. What you said about this quantity, it only has a magnitude, no direction, right? So that is very important. Use the equation. This is the equation we use for work if we calculate. So it has the force applied, it has the distance or the displacement, it has the cos if it moves horizontally. So it can be the cos, positive cos, and the negative. We'll talk about it. We'll see as we move along. Now, what is very important, this appears. Remember, in question 2, you've done the force diagram or free body diagram. Even here, there's a force diagram and a free body diagram. So there is a lot of marks that you can grab here. So, but what you remember, we are going to use this formula, and if we want the net work, all the forces that are acting, we're going to use this one, right? Now, these are the forces acting in positive, negative, or no work done. So this is positive. This is cos 0 degree. This is cos 180 degree. And then here we know that we are going to, it's a friction. Your answer, it must be minus. This one is going to be positive. There are no work done if it's working vertical, right? Now, we out of time. Now, the first diagram, I'm not going to dwell much on it. I've alluded to you. I've explained what is the first diagram, what is the free body diagram, and how do you determine what I want to emphasize are the marks. Look at the marks as to how many marks that you are going to get. Now, the formulas, this is the table or the data sheet that you are going to get for the formula or the equations. So select a correct one. You must select a correct formula, right? Let us go to the problem, because what is very important, the key here, how to solve the problem. A 6 kg box is pulled to the right, right, on the horizontal surface at 10 meters or for 10 meters by a force of 20 Newton. The box is experiencing a constant frictional force of 3 Newton during this motion, right? Now this box is being pulled in the direction, the right. Now define what is work, right? You must know what is work, right? Now draw a free body diagram of this. Look at the marks. It is telling you how many forces you must draw, which is 4 forces. So it means 4 marks for 4. Calculate the work done by each force which is 6 marks. Calculate the work net done by the object. This is the total work that you are going to calculate. This is the work each, which is 3 marks, 3 marks. That's why it's 6 marks, right? Now, let me give you the solution. What is, they say, define work done. Work done is a product of force acting on an object and the displacement in the direction of a force. That is 2 marks, 2 or nothing. Now, draw a free body diagram. Here, they say we must draw what? The force diagram, not a free body diagram, right? A force diagram. So here, there is no dot. It must represent the structure. So this is the normal. This is your gravitational force. This is your pulling force. And this is your frictional force, which is lesser than this one, right? You've got your 4 marks. There are 4. Now, how do you calculate? F of you can label F of F, I mean W of A or W of, those are doesn't matter. But WF equals to F change in the displacement cos. This is the formulas that I said you get it right. Pick a correct formula. Then you pick it right. Then you are given the force of 20, dragging the object at the displacement of what? 10. Then it's moving to the right. It's cos 0, right? Moving to the right is cos 0. Then you calculate, then you get your answer as 200 joules. That is the SI unit of the work, 200 joules. Then you come again. This is your 3 marks, right? Then you take the same formula, but now it's moving to the left because there's a frictional force that is acting upon this one. Then this one is a frictional force taking at the 10, all right? The displacement that you are given. Then, but now moving to the left, we use 180 because of the friction, which is 180 degrees. Then it must be negative, all right? Then it doesn't mean that the work that has been done is negative. Remember, work is a scale, a scalar quantity, right? Remember, it's a scalar quantity. It doesn't show the direction, but it's negative, 30 joules, right? Now, they say the net work that has been done. We are going to add the two. You are adding your answers. Remember there, you got 3 marks, then it's 6 marks, right? You got your 6 marks, then the other 3 marks is for you. Then you say net, W net, which is all the work that are there, is going to be WF, which is that one, WF omnian, which is friction, which is that one. Then you add the two. This is then you take that. This is the. You see now we are working on the answers. All right, it's doing with the answers that you have got in at the beginning. Now this is, you put the 200 there plus the 3. Now we know that positive minus positive times negative, then you get your answer. You know that's negative. Then you resolve your answer with a calculator. You get 170 joules. So that is how you calculate. That is how you calculate. So you must know which, if you are doing the angles, because it's horizontal, it's the 0 and the 180, right? It's very important. The same question, but now the angle, the force is acting at an angle here, right? They can say, draw the free body diagram, depending on the marks. Now, draw the free body diagram here. They're given a free body diagram. Then calculate the work done by each force, which is the friction and the one that's pulling on the right. Then 6 marks, and then you calculate the net, is what we did the other one. Now, the free body diagram, you can use, I've shown you there are 2. You can use this one with a component, or you can use the one that has the angle there, then the force there, the force there, the force there. Then you label them, because you must label this is, and this is. All right. So I must do correctly because they must touch. Right. So you can use this one, or you can use this one with the component of this forces or resolution of forces. So you can use that one. right? So same method. You go to a data sheet, you want the formula. This is the formula that we use. You cannot get a mark without substitution. Even if you can put the formula, it's correct. But if you don't substitute, you won't get a mark. So substitute, read the question, then you substitute. Maybe you have forgotten to substitute this one, right? Then you substitute only 10. For the fact that there's something that they're substituting, then you can get the mark there. Then you get wrong maybe somewhere where we are going to get, right? Now, same applies. You go to this one, you pick up the correct, then you go there, you get this one. Say maybe you forget to put there, then you only put 10 and cos theta. We are going to be wrong here, but you're going to get a mark there, then wrong there. All right, but at least you shall have get something because you have substituted. Substitute with the number that is there in your problem statement, right? But I wish you to get the whole 6 marks because it's easy to calculate, right? Then you go to the total. Then that is how you add this one plus this one. Then you get your total marks, which is your total 15 marks, all right? Now, elasticity. This is the question that has a lot of definitions. This is the question that needs you to define before you can calculate. This is where you must get marks, right? Now, what are you going to define? You're going to define the deformation, the restoration forces, the pressures, and all of this. Now, these are the definitions that are there at your disposal. So use those definitions. They are there at your disposal. So you need to use them. So a defined force, a deformation force. An external applied force can change the shape of the volume of the solid material. It's a if I squeeze something, I make what? A deforming, because the object is going to be change the shape. That is deformation, right? Restoring, when I release the force, the object, it go back to its original. So that is restoring, right? So those are the definition that you need to know. These are the examples. I know that you are there. If I pull the string downwards, then what is going to happen with the string is going to expand. Then that is a deformation. If I leave it, it goes back to its original, like this one, then it's a restoring force, right? Right. So strain and stress, that has a definition as well. What is a definition of a strain? What is a definition of a stress? Now, a stress, it's when force over area, force acting on an area. So that is this way, it's a stress, not the stress that we normally have. This is a stress according to scientific. Now we have the strain, not the strain of a stress, but the strain of this scientific. It's an extended length over the original length. Extended length over the original, or the change of length over the original length. These are what they are telling you. This will get it in your data sheet. These are the formula that you get in your data sheet. Define these terms according to the definition. It's going to be easy. Go to the data sheet. You look at the strain. This is the a formula for the strain. Oh, what is this? The change of the length over the change. Over the original. So then you say it by the width of mouth, right? Then you'll get your full marks, right? Now, elasticity in terms of Hooke's law. Hooke's law is very important. You must know how to state the Hooke's law. Hooke's law says, that I want to emphasize to you is the stress is directly proportional to the strain. Now, we say if it's directly, what is happening on the strain, it must happen to a stress. What is happening to a stress, it must happen to a strain. So if you stretch up an object, it moves there. Then the stress, it stretches, and the strain is stretches. So there is a direct proportionality. So you have a graph that is straight there until there. This is the direct proportionality. Once it just bend, is no longer, this is no longer a strain. or now we call it elastic limits. It has reached its inelastic limit once it's starting to bend, because it won't go back to its original. So once it can go there and go back, then we've got what? A strain. Hooke's law. So the Hooke's law, it says when you bend, the stress must be directly proportional to the strain. That is Hooke's law. So you can do it with a graph. Remember, we said interpretation of graph is very important. If you interpret the graph, you must know how to interpret graph, right? So here's the activity that I want us to do very quickly. It's only take us a second to do it. Now they want us to study the pictures. These are the pictures. We've got the clay dome, we've got the wax, we have the elastic bands, we've got the clay. All right. Now the plate dough. So the plate dough there, once you do it in an ordinary, it's a shape. Once you just press it, would it come back to its normal shape? That's the question. The wax, if it's a straight wax like a pen, then I bend it, will it go back to its original? A rubber band, if I stretch it, would it go back to its original? The clay, if I play with the clay, will it go back to original? So they want us to choose. All right. Now I'm giving you tip. All right. Now, if anything that does not go back to its original, it's what? Perfect plastic. If it go to its original, back to its original, it's perfect elastic. Right. So we need to choose which are perfect elastic, which are perfect plastic. Right. If you press it like this from the original, it won't go back to its original, right? This is a perfect plastic. Good. This, if you bend it, a wax, if you toss it with a fire, would it go back to its, like a candle, would it go back to its original? No. What is that? A perfect plastic body. A rubber band, if I pull the rubber band and I leave it, will it go back to its original? Yes. What is it? Elastic. It says it itself. It's a elastic, perfect elastic. Now a clay, if I bend the clay, if I make a whatever object that I can make with the clay, would it go to its original? No. What is called a perfect plastic. So that is how. These are the definitions. So I'm talking about the definitions so that they can make it easier for you to understand what we talk about, perfect and elastic and plastic. Now, yes, the one that I want us to do, I'm looking at the time, it's running away. So they want us to calculate the stress, and then they want us to calculate the strain. We are giving a 3 meter long steel of a diameter, not a radius, diameter, the whole diameter. Now of 80 millimeters, and then stretch with a force of 30 kilonewtons, and in extend at 0.4 meters. So now this is what is happening there. What you are told. They want us to calculate the stress and the strain. All right. We know that stress, you've got this, is equals to force over area. That is your. Now, if you check, we don't have an area. We need to calculate an area first. But how do you calculate an area? Because you've got a radius there. So it means you're going to use the formula area equals to pi d squared over 4. Right? This is the formula that you're going to use. But I'm going to give you a solution because of time. Right? But I'm giving you because what? We have the diameter there, right? That's why I'm telling you, right? This is the solution. You can copy it faster, but you relate to it as in we are doing. But we are given here, we are given the millimeters. We need to convert the millimeters into what? Meters. So if we do that, how we do it? So it means therefore we need to divide by 1,000 to get the 0,08. Right. The square, don't leave the square there. Don't leave the square. All right. Don't leave the square. Then you calculate, you get your area. Then this area is the one that you are going to use to this force, because remember we are given the force. The force was 30 Newton. So it means it's 30 multiplied by 1,000. Hence we get this. All right. So then you take your area. This is the area, it comes here. Then you get your answer. Then you calculate the strain. The strain, there's a formula. A strain is a length, the extension of a length, divide the original. Then you are given the extension. The extension they said is 0,4, right? 0,4. Then it means, therefore, what you do, if it's 0,4, you divide the 0,4 by 1,000. It gives you 0,004. Divide by 3. The 3 is the one that you are given as the original length. Remember, yes, the original length is 3. Then you divide by the 3, the original length, then you get your answer. Then you have calculated the stress and the strain, right? So I think these equations, problem the questions are very simple. The only thing that you must remember here, we calculated this one because of the diameter, right? Now, Pascal laws, question 6. Pascal laws, you must know to define the Pascal law. And then most of the thing here is to calculate. It's either you'll be calculating the force, we are going to be given the area of the small pistol, or the force of the big pistol and the area of the small. Then you calculate the force of the smaller, or vice versa, either of the two. But this learners, is very important. You need to interpret this using this formula, because this is the formula that you are going to get. You'll be giving 3 and calculate 1 unknown. So whatever that you are giving is either the area or the force. What you need to know, it's a cross multiplication. This one, it multiplies with this one it multiplies this one to get the answer. Don't try to maneuver something that you first you pick up the question that it is, then you substitute, then you start calculating or cross multiplying. So state the Pascal principle. Then they say give 2 examples. Then there's calculations thereafter. Now these are the answer. The Pascal principle, mainly it says in the continuous liquid in equilibrium, the pressure applied at the point of transmitted or is transmitted is equal to another part of liquid. This is simple. It tells you about the area A. The pressure, because pressure is force over area. The area A is equals to area B. Force over area is pressure, or is what we did is a stress, right? So these are equal, right? So it tells you these are equal. If you use this formula to explain this, you'll never go wrong, right? So give example. What example can you give of which are using hydraulics? Car lifts. We use hydraulics, bricks. There are many. They say doctor's chair, and then there are so many. So I've used 2. So example, you'll be required to give example, right? So now the question, go back to the question. The question, it says the force, we are given the force there. Then we are given the distance, the area there. We are given the dimension, the diameter. Once we have the diameter, I told you that you need to calculate area with pi squared, distance squared over 4. That is what we are going to do, right? Is what is needed first. So this is the formula. This is what I did, right? Now you are given the distance there. The distance was in millimeters. We convert it to kilometers, right? Sorry, we convert it to meters. Sorry, because it was millimeters. It goes to meters. Then we have the area. This is the area that we have calculated. Then we have the formula. Write the formula, because this one they won't mark it. They will mark starting from there, the answer. Then they mark your formula, because they want you to calculate this. All right. Now, one of it, they want to calculate one of it, right, which is F2. Then they are giving you this one, which is the force, all right? Then you divide the force by the area given on the formula. Then the one unknown is this one, the force that they want you to calculate. And then you take the area that you have calculated there. Then you start calculating. How? You cross multiply. Start cross multiplying. Then you get your answer. All right. So capacitor and capacitance. Capacitance is the definition of a capacitor, and the capacitance, that is you must familiarize yourself with. And then formula. These are the two formulae or formulas that you are going to get in a data sheet. Then you must know the factors that are affecting capacitance, which is the length, area, and the distance. Those are the factors. Then the calculations, therefore, reading the scenario, right? This is the very easiest one. Now, they say here, at a plate of, the plate of capacitors of 3.8 millimeters apart are stored, and stored a charge of this. This is a charge of 2 coulombs each. Now, the capacitance that it has of the capacitor is this one. Now, calculate the potential difference between the plate. What is capacitor? Capacitance, road capacitance is charge over potential difference, right? Charge over potential difference. Now, out of this, they want you to calculate this one. This is the formula that you got from here, right? They want you to calculate the potential difference, which is V. Don't manipulate the formula. Calculate it as it is. You are given the capacitance of a capacitor, which is 4 times 10 exponent 6 equals 2. We are given the charge, which is 2 over V. Then what you do, you cross multiply. This, it goes there. This is over 1, it goes there. Then you've got you've got 2 times, whatever way you can write, 2 times 4. You've got 2 equals 2, because this one is multiplied to this side. Then we've got 4 times 10 exponent 6 multiplied by V. Then you can calculate when it's like this. All right? So this is how the cross multiplication is very important. So you need to cross multiply. So then this is going to multiply. Then you are going to divide by 4 times 10 exponent 6 both sides. Then it cancel out. You are going to left with V the other side. Then you say 2 divided by 4 times 10 exponent minus 6. Then you get your answer for this 3 mark. Then here they calculate the area of a plate. They want you to calculate the area of the plate. You go to the formula. Capacitance is equals to permittivity of space. Then you've got what? You've got what? Area over, it's a distance over area. Let us go back and check. It's area over distance. Yes, it's area over distance. I'm correct. It's area over distance. Then this is the formula that you are going to get there. Then you start, because you cannot get marks without substituting, right? They want you to calculate what? An area. Where is it? An area here, right? What is easier for us? You've got the capacitance, which is 4 times 10 exponent 6 equals to permittivity, it's 885 times A over the D. D we are given there is going to be 0,00 something, isn't it? That we are going to convert this 0,08, if I'm correct, right? Then we are cross multiplying this and this one. This is over 1, it goes there. All right, then this times 1 is going to be 8,5A equals to, this is going to be 4 times 10 exponent 6 multiplied by 0,08. If it's like that, then you get your answer. Then at the end, you are going to divide by this number, both sides. Then you get your A. That is your area, right? The last question, because I've jumped, then we are, the time is against us. We have eaten up time. Now, light. I've jumped other questions, then I'm coming to light. This is my last question that I want to do with you. Light, this is very important. This is from paper 2 to paper 1. So light, what you must look at into light, the dispersion of white light. The dispersion of white light when it goes through the prism or the glass prism. So it's going to produce the component of colors. Now, what is the dispersion? It's when a white light passes through a prism or bend in a prism, it bends in a prism, produces a component of colors. So the white light is very important. You mentioned the white lights, and then when it bends through the prism, it produces what? The component of colors. That is the dispersion. Or they say, what is the phenomena called in this regard? Then you say dispersion. Now, we look at the reflection of light. Reflection of light, what is very important, is a light rays that is going to strike the surface there. Then it reflects, right? Now, you have an incident rate. This is an incident ray. Then if it strikes at the bottom there, which is the surface, then it reflects. Once it starts, it's not bending, it's changing direction. Sorry. So it changed direction. Once it changes, don't say it bends. This one, it doesn't bend, it's change. This we talk about change. Changing direction. So it's going to change direction. Once it changes direction, it reflects. We call it reflected rays. This is an incident ray. That incident rays and reflected rays, they are divided by what? The normal. There's a normal line there. Then that normal line is going to form an angle of incidence and the angle of reflection. So this angle are both equal, right? That we got from the law of reflection. Law of reflection, it says this angle 1 and angle 2 are equal, right? Now we go for, we are going to get the refraction. This is reflection, it's a change. Refraction, it's bend. I want you to get this. This is a change, reflection, change. Refraction is a bending. And we've got the critical angle and the total internal angle. So reflecting angle. So this, what has happened? If the light, the incident rate come from this media to the other media, is going to refract there. It bends. So this is the refraction. So it bends. It moves away from the normal. So once it moves away from the normal, this is going to be the incident ray. This is going to be the refracted ray. So the refracted ray, it moves away from the normal, or it bends, it bends away, because it bends. We're talking about bending, bends away. The critical angle, it must have an angle of 90 degrees from the normal to the refracted ray. This is the refracted ray. So it's going to form the angle of 90 degrees. Then we've got what? A critical angle. So now, if this incident ray is moving internally, so it's going to increase the angle. Once it increases the angle of incident, this angle of incident is equal to this. They are increased, they are more than 90. So we talk about the internal reflection. internal reflection. It's bending inside, internal reflection, right? So now I'm coming to close with this question. Then we come to closer. Now it says, the diagram below shows the reflection of light strike into a mirror at the 30 degrees angle of the incident. You've got this light, A and B. Now we know what is A, we know what is B from the previous. We know what is 1, you know what is 2. We know what is the line in between, is what they are going to ask. Now they say, define or what is the reflection? What is the reflection? Is the changing of the right, changing direction of the rays, right? You cannot say it's bending, it's changing, right? Now use the diagram below or above to write the names of the following. What is the name of AO? AO is the incident, is what is happening. Incident, happening, is what is where it starts. Incident, happening. It's an happening of the light ray striking the surface. So it's an incident ray. What is OB? OB is the, once it changes direction, it reflects the other one. So it's a reflect ray of incident. Now then, what is M? Line M, that it's a normal. We call it a normal line. Then what is angle 1? Angle 1 is an angle of incident. Angle 2 is an angle of reflection, right? Then what is the angle 2? The value of angle 2. What is the magnitude of angle 2? Remember, angle 1 is 30 degrees. Then I told you the other side, this must be equal to the other one. Angle 1 must be equal to angle 2. So even angle 2 should be 30 degrees, right? So it's 30 degrees. So those are questions that they come. Look at this. It's 1 mark, 1 mark, 1 mark, 2 marks. So you must grab those marks. Grab and run. Those are 1 mark free. So they just telling you that, right? So what is very important, what message I want to bring to you is this one. This is the definition of the reflection, the change in direction of the wave. Now the change, the change. It's what you must remember, right? This is what I want to bring to you. Success isn't always what it seems. I want you to look at this picture and think of it. Look at the man at the top and look at the men at the bottom. Those at the bottom, they say it is too easy. They've never been there. Remember, they've never been there. Everyone can look at you and say, what you're doing is too easy. It doesn't know the road that you have traveled, the journey that we have took. Look at the man at the top. Before he reached the prize, he went through obstacles. It's oozing blood. Go and ooze blood tomorrow. You will be successful. This is the end of our lesson today. Thank you for watching this lesson. See you next time. Goodbye.